Okay, so are the days of manually debugging Kubernetes errors officially over? Azure just released the Agentic CLI, an AI that promises to fix complex problems with a single command. Today, we are finding out if it really changes the game. Hi everyone, I'm Lionel, and as a Microsoft MVP, I'm always looking at what's next in the world of development. I think we are at a fascinating point where AI is starting to change our entire workflow. For years, the model has been simple, we had to learn the complex language of our tools, but now that's beginning to flip. Our tools are starting to learn to understand our language. And the new Agentic CLI for Azure Kubernetes Service is, in my opinion, one of the best examples of this shift in action. It's not just another feature, it's a glimpse into a new conversational way of troubleshooting complex systems. So in this video, we'll break it down into two key parts. First, we'll explore exactly what the Agentic CLI is and how this new conversational approach works. And then we'll jump straight into a hands-on demo where I will install it and use it to solve a real-world problem just by asking questions. As always, timestamps are in the description below, so feel free to jump ahead to the part that's most interesting for you. Alright, before we jump into the terminal, let's fully understand what this tool is, because the documentation describes it as much more than just a chatbot. It's officially defined as an AI-powered troubleshooting and insights tool that brings advanced diagnostics directly to your terminal. The core promise here is massive. It's designed to help us diagnose and resolve complex issues without needing deep Kubernetes expertise or memorizing obscure command syntax. So what does it actually do under the hood? The FAQ describes it as a local assistant. It interprets your natural language queries and autonomously executes diagnostic commands using native toolsets. These toolsets allow it to integrate seamlessly with Kubernetes events, logs, inspector gadgets, or Azure APIs to gather telemetry. But it goes way beyond just gathering data. According to the documentation, it performs intelligent analysis of your cluster state. It provides an AI synthesized summary response, a root cause analysis with supporting evidence and remediation suggestions tailored to AKS best practices. And one of the most interesting features mentioned in the docs is that it integrates with Microsoft's extensive Kubernetes troubleshooting knowledge base. This means you are getting insights backed by their internal expertise directly in your console. Now, we cannot talk about an AI tool in production without addressing security and configuration. The documentation is very clear on this. First, regarding the AI model itself, the agent doesn't include one built-in. You have to configure your own AI provider, whether this is OpenAI, Azure OpenAI, or Anthropic. This gives you control over where your data goes. Second, regarding permissions, the agent respects your existing access controls. It inherits the user's permissions from the Azure CLI. Crucially, it operates in read-only mode by default. It can query logs and describe resources, but it cannot delete pods or change configurations unless you explicitly authorize a write operation. This follows the principle of least privilege, meaning the AI cannot do anything you don't already have permissions to do. To maximize the effectiveness of this tool, Microsoft outlines several best practices. You should start with broad diagnostic queries like what is wrong with my cluster, and let the AI guide you down to specific issues. Use descriptive problem statements because providing context about the symptoms leads to much better analysis. And finally, leverage historical analysis. You can ask the agent about patterns and trends in cluster behavior over time, which is incredibly powerful for spotting intermittent issues that are usually hard to catch. Now that we understand the power of the rules of the game, let's install it. Now let's jump straight into the terminal and get this running. We are going to break this down into 3 steps: the prerequisites, the installation, and then the usage. First, let's do a mandatory environment check. You absolutely need the Azure CLI version 2.76 or higher for this to work, so go ahead and run AZ version to verify this. If you are on an older version, the extension simply won't load. Also, ensure you are logged into the correct subscription using AZ account set and that you have configured access to your cluster with AZ AKS get credentials. Next, we need to install the specific extension. Run the command AZ extension add. Note that the documentation warns this might take 5 to 10 minutes to complete, so don't panic if it seems to hang for a moment. Once that is done, you can verify it was successful by running AZ extension list and checking for the AKS agent entry. Now, before we initialize it, we need to talk about the AI model. You need to bring your own API key. Microsoft strongly recommends using newer models like GPT-4o or Claude Sonnet 3.5 for the best performance. Specifically, you want a model with a high context size of at least 128,000 tokens. And if you are using Azure OpenAI, which is the recommended path, make sure you deploy the model in a region where you have quota. A pro tip from the docs is to select a high token per minute limit, ideally upwards of 1 million TPM to ensure the analysis is fast and doesn't get throttled. Make sure you have your API key and your Azure API-based endpoint ready. Remember that the endpoint usually ends in openai.azure.com. Now let's connect everything. Run the command AKS agent init. This starts the interactive configuration wizard where you will select your provider like Azure OpenAI, enter your model name which should match your deployment name, and paste your API key. Once you see the message LLM configuration set up successfully, we are ready to go. Now, to properly test this, let's break something on purpose. I'm going to deploy a pod that I know will fail by specifying an image tag that doesn't exist. I run the command kubectl run broken demo image nginx wrong tag 123. If I check the pod, I see the classic image pull back off error. Instead of describing the pod manually, let's ask the agent directly. I run AKS agent, why is my broken demo pod failing? The tool enters interactive mode and starts analyzing. It should correctly identify that the image cannot be pulled because the tag doesn't exist and suggest updating the deployment with a valid tag. Okay, so then I asked the Agentic CLI how we could solve the problem. As explained before, it doesn't launch anything without your approval, but it proposes to run two commands. I explicitly ask it to delete and recreate our pod with an existing tag. I just need to give my approval for both commands and the pod will be recreated and running. I really like the fact that you can easily switch from chat mode to join the shell and come back to the discussion with the Agentic CLI. This allows us to really work together, and as we can see, everything seems fine now. Even the Agentic CLI confirms that the pod is now running. And finally, a technical note for the advanced users. The documentation mentions that an alternative to the default toolset, you can enable the AKS MCP server with the Agentic CLI. This experience spin up the AKS MCP server locally and use it as the source for telemetry instead of the standard toolsets, giving you even more flexibility on how to gather data. So the Agentic CLI is an incredible tool for fixing fires when they happen. It really feels like having a senior engineer in your terminal. But let's be honest, the best way to handle Kubernetes errors is to prevent them from happening in the first place. I have curated an entire playlist called the AKS checklist. It covers all the production-grade best practices I use to secure and stabilize my clusters. Thank you so much for your support on this channel. Please consider leaving a like if you found this video useful. Click right here for that playlist, and I'll see you in the next one.